So here outside I have some neglected rocks, and these all contain fossils. So here is a part of a trilobite, and this is probably the midsection. I'll try getting rid of it, but these have been here for a few years and I haven't really done anything to them. So the finger back, and here's probably a spear of Brachiopod. So the thing about keeping the fossils outside is that even though they're protected by rain, so they don't get soaked, so the chemical weathering from the interaction with the water is less, but there is moisture in the air that does penetrate the rock, so the breakdown is slower, and you do get temperature differences which expands and contracts the rock, and so slowly wears it that way. So we'll just have a look at the fossils, and we'll see what is really worth keeping. So here we have quite a large rock. It has a trilobite, and looks like the aft section, so the tail is broken off, and the mid section and the head goes into the rock, so you need to remove that. See, we have organisms already starting to colonize it. That's spider, and if you look around there, you've got different colorations. So you've got looks blue, bluish grey, and brown. So the blue is probably anoxic event, so where the rock's been depleted of oxygen. And here we have some more fossils in the actual rock, so that doesn't reveal much. And here we have another one with a Brachiopod. So this one you can see, the light's not that good. Okay, so if we zoom in, you can see closer details inside the actual Brachiopod. Sorry, there you go. So this is infilled with material. The organism's pretty much decayed, and so is the shell. Shell's decayed, and what you get is an internal and external mold. Oh, sorry. What is the formation? This is the Humevale Formation. These fossils come from New Mountain Disappointment. So, Colombinane fossil, and I've gouged out a little bit just to excavate the fossil a bit more. So that needs to be excavated more. And then we have a smaller fossil, another Brachiopod. So most of the fossils in this formation are quite small. They're sparing as well. So if you look around, there's another Spirifer fossil. It's a Spirifer Brachiopods mold. You can see the cavity. So you've got the top part, which is near my fingernails, will be the external mold, and the rest of it is the internal mold. There's another fossil there. You can probably find quite a few fossils in that formation. So with this rock, as it erodes, you can see it forms a crust, and this is mainly, looks like iron oxide, and this is indurated, so it's actually quite hard. So this material is soft, and this top layer is hard, and as you can see, it's cracked as well. So that is pretty much a top layering of the rock, and you can see how the formation, whatever's left of the formation after it's been eroded. Another fossil we have is an internal mold of a gastropod, so you can see the swirls. So that is a fossil you don't find too often in the Humevale Formation that I've seen. And around where I live is rock that looks the same pretty much yellowish brown colour, but it doesn't have any fossils in it. That's the Humevale Formation. Never found any fossils in that. And here we have another Brachiopod. So this is quite a nice external mold. So this is the top part of the shell, or even the bottom part. And here's some more fossils there. So we've got quite a few here, but there's nothing really spectacular, nothing really large. So this one is probably only a centimetre across. Then we have another Spirifer Brachiopod, and here we have some more fossils in there. Looks like a Brachiopod internal mold. As you can see, the coloration, that looks like it might be either a Brachiopod or a sponge. Here's another Brachiopod mold, and this rock is actually quite soft, so after you collect them you can actually damage it quite easily. And here we have another, I think that's a fossil. It's a bit hard to tell if we look around. No, so this is the surface that was exposed, and you can see how the crust is formed. And here is another rock. This doesn't have any fossils in it. Probably could have in the center if I broke it open, but not there. And here is another internal of a Brachiopod. So you can see the internal molds, damaged, external mold. And sometimes in a formation you can get rocks like this. So this is indurinated. It means that it is pretty hard rock, very hard to break. This dark black rock, you can see quite thick. It started to fracture because it does corrode. And here we have some softer rock down below. So this is more than likely it's been probably iron and magnesium. I haven't read anything about it, so that's just a guess. If anyone knows about it, you can see when it's cleaved, it gives pretty much a fine surface. So that could be a crystal structure that we're looking at. And if we look at the top, you can see the fractures have been infilled by eroded material. So that's what you can also find in these Humevale Formation, as well as you can find laminated. So you've got dark and light laminations in this rock. So that one is not as good because on the other side you can see it's been eroded, so it covers up the lamination, so you wouldn't see it at the surface. Most of the rock that we see is massive. It means you don't see laminations, you just see, so you don't see any laminations in that rock, it's just all quite thick. So this was probably deposited all at one time. Probably a turbidite, could be. That's just a guess because these seem to be deep water sediments because they're all fine grain. So this is probably a siltstone, not a mudstone. You can still see the crystals. It's not a sandstone because you can't see the individual grain. So siltstone, probably a coastal, probably not deep sea if it's not mudstone. Probably intermediate between the coast and the deep sea. So a continental slope, I would gather to guess this would be. Here's a broken piece. You can see where it breaks on the laminations, but you can't really see a distinction in the laminations or the actual rock. And sometimes you can get really, so this is probably iron. got quartz in here, so this is probably an eroded surface. The quartz would have come up through metamorphism pretty much. So in I have videos on gold, and there's also good videos on YouTube about how gold is deposited through low-grade metamorphism when the lower rocks are depleted of gold, and that is moved to the higher up in the elevation, but still lower in the rock, and deposited in fractures. So, but that's not what this video is about. So the last fossil we have is another Spirifer Brachiopod. That's an internal part. The externals are pretty much gone. And here we have some more external molds. Here's another fossil, and that's about it. So that's what you find with the Humevale Formation. Not really that good a deposit for looking for fossils, but also very interesting anyway. So thank you very much for watching. Have an awesome fossil collecting time. Thank you and goodbye.